I'm also a merchant marine, but I'm not going to qualify myself to compare to anybody that's being trained in this facility. So I have been in the back, just to give you a little bit of background. I was on the service side, marine air conditioners, servicing electric, as well as marine air conditioners, and years of looking at existing known brands. I was stuck and confused by why there was an innovation. And what we have is, as Archer Power Solutions, when we switched from service company to actually manufacturing company, I'll give you some good, I'll go through some slides here. So we quickly realized that there's air conditioning is typically stuck in the 1980s technology, and there's a huge potential out there in terms of the technologies available there. It's just that how much will it take for the companies to adapt it? So this is the typical what you would see as an alternating current based air conditioning installations around the world. Just to get that cold air going. But there's an easy way. I strongly believe off-grid is the way to go, or distributed power is the way to go. And part of that is this direct current, solar panels, and the battery capacities are regularly increasing, as you all know, since you have the background to the surveyors. So this is just what we do. Just quickly, I'm going to talk about the company, but I'll dive into the air conditioning market as well. So we're focused on off-grid, focused on direct currents, and what better platform than vessels? House banks, direct currents are pretty much, we pretty much predominantly focus on the retail market, recreational marine vessels, as well as the commercial, but much smaller in size, not like the big ships, cargo ships or anything like that. So just as a background about Archer, and this is just our only mention of the company in here. We launched into this space in 2021. We have the second generation. This is what you're seeing here is the MA37X12P. It's a true 12-volt direct current air conditioner. There is no alternating current in any of the components. To be able to get there, we had to develop our own software, our own PCBs, electronic control board, and our own relay board, basically. And we adapted things like electronic expansion valves and their drivers, and we synchronized the variable speed compressor to the electronic expansion valve, which was quite an undertaking. And we got recognized by customers. As I said, we predominantly do retail sales, and we're small, as I said. We got recognized by people putting up on social media. We started assembling them actually here, everything in Maryland in 2024. We have some success overseas as well, getting recognized, and slowly we're seeing being used in the U.S., particularly U.S. law enforcement and foreign coast guards, and they're putting them into interceptor type fast boats. So you have seen this probably everywhere since you do surveys, almost all the boat yards. What's happening is that people are just for a solution. They're buying off the shelf market items. Yes, you can go to Home Depot, get a $200 window unit and put it in your boat and power it up from alternating current, shore power. What's the harm in that? The only thing is that they're not designed for that. And secondly, they are not properly integrated to the boat. So for it is the electricity factor. That's the biggest risk, fire risk. And they're also not designed for the marine environment. For example, we are using aluminum 6061. They will never rust. They will oxide on top, but you don't see any kind of rust on this type of aluminum. We are also following, for example, UL standards, ABYC, Coast Guard, the parts, wiring, every component. Lot of you won't see that on the commercial equipment that's units. That's another thing that you typically see, using those Honda generators, trying to power it up air conditioners with soft starts. And it's a regular thing. And I'm sure you came across as you're walking around and surveying boats. This is typically what I would see a lot. And what's happening is that they are putting it there. It's one thing that bothered me. It wasn't even tied up or anything like that. And when they're running, of course, the carbon monoxide depends on the wind, which way it is going. If the ports are open, it's going right in there. There's a port right there that's open. And or if you're the boat next down the anchorage, you're the one getting all that carbon monoxide with the smell of the exhaust. So how does it all come together here? So I'm gonna now talk about survey-wise, what is at risk, where's with these designs. So obviously, one thing in the marine industry is with air conditioners. Obviously, typical installations in the US, just Coast Guard, UL, whether the wiring is UL rated and the BTU listing is actually compliant to ASHRAE. In the marine industry, unfortunately, anybody can put any label as a BTU rating. I'm just putting it out there. They basically go by compressor rating. They take the compressor rating. If you actually look up the compressor of known brands, you look up specifically the compressor and compressor's technical tables. I'm not saying it's it actually is not matching what that label of that unit is. This doesn't say, I'm not just saying that one specific company, or it's typically across the board. You don't see this. We follow ISO 7547. That's basically probably you are all familiar with. It's used on commercial air conditioning, commercial vessel air conditioning. And we benchmark it to 95 Fahrenheit ambient temperature, assume that 89.6 Fahrenheit incoming seawater temperature. We, during the last, I think it was just last summer at one point, right outside of Miami, the bay itself was 101 Fahrenheit temperature, seawater temperature. And that is, seeing that, we actually tested up all the way to 108. And most of the air conditions at that point, they will start to shut down. With that kind of a marine air condition will start to shut down unless it's specially designed to run at that temperature. But so that's the limitation of these typical commercial products out there. I haven't seen any. There are that many companies that will basically build the products to ISO 7547. So the next thing is, of course, obviously fire risk. I have seen installations of any, I'm not talking about ours, other marine air conditioners that are just in the engine compartment that would basically obviously suck the air from the engine room and circulate it back into the boat, which is absolutely no-no. And there are other safety features that it's important to look at. One of them is compressor overload protection. Compressor overload protection, it's an electrical protection mechanism where the pressure inside the compressor builds up, which usually happens either by there's a blockage There's actually we actually put a dryer in there. After the presentation, we can all get up and gather around the unit, and I can show you the components if you would like to what to look for. That dryer might be blocked. Most marine air conditioners come out today as reverse cycle. That will get stuck and build up the pressure. That's one of the weakest pull components of those air conditioners that have reverse cycle. That will build up and basically immediately will start putting out heat. And if the wiring associated or if anything that's touching the compressor at that point can heat up fairly fast. So one of the things that we specifically recommend and caution in our manual as well, just make sure it's not in an engine compartment, but make sure it's not, these units are not ignition protected, basically. So it needs to be away from fuels, it needs to be away from anything combustible. So compressor control and overheat protection. So when you hear these variable speed compressors that are coming into the market, they may have actually an inverter, which means they are actually designed to speed up and down with using an algorithm which has actually sending a signal through megahertz and speed up the compressor. Those are drivers also generate heat. So that's also something important that making sure that those drivers have heat protection against heat. And that shouldn't be just a warning on the unit, but it should be translated to the user screen. They should know, the typical customer should know that there's something odd going on that will cause power failure. Another third bullet is compressor control connectivity loss. That's basically is when there's power, the lines are disconnected, and that could happen. It can happen through vibration or something like that. If somebody tried to put something behind reach in there by mistake, pull the plug, that could happen, and that's going to cause. Depends on the wire. It may cause, for example, it may cause where the system may override errors and things and start heating up, and the end user may not be aware of those issues. Compressor voltage protection, that's basically is a range where the unit will shut down and operate. It would typically, ours is 11.9 and it will shut off at 14.3. Just to give you a benchmark. That's commonly, you will see that you will see typically on most marine air conditioner, well-known, well-established in the market, you will see the compressor overload protection, you'll see the voltage protection, but you will not see the other two, for example. Compressor short circuit protection, you don't typically see it as well. And then relay board overheat protection, that's I have never seen, unless you're familiar with a brand that will actually put that. We put specifically a sensor on each PCB that will detect the temperature. If something is warming up, it will immediately start alerting the customer. Main controller overheat protection, similar. These things can, anything electronic for one reason or another, if the customer, due to bad installation, if they didn't follow the wiring gauges or something like that, if it isn't drawing enough electricity, that will cause the things to heat up. Refrigerant pressure alerts, that's basically high side, low side. Whether the unit will tell you typically whether there's a refrigerant leak or it's not pushing the refrigerants at the right levels to the evaporator. And then last item I want to mention is water pump error. That's important, obviously. If there isn't enough water going into if the water pump shuts down, basically the condenser will start heating up. As the condenser heats up, that's basically will lead to first compressor overload. And compressor overload will start leading up to potentially, you will see that the heat will start traveling through the wires to the compressor driver, compressor controller. Thermodynamics is fascinating. I've seen heat travel as through when we are doing research. I've seen heat. You can put something hot here, put a copper wire, and then put it between that, and then you can put a metal plate here. While there's heat here through that copper wire, this plate will start heating up. That could be 3-4 feet between them. It's fascinating, and that's basically is like why these electric wires and everything else come into play, how important it is. It gets a little bit easier when you take alternating current out of that equation. So direct current is very straightforward. That's very forgiving depending on the circumstances. And if the unit is, and everything is installed correctly, if there are enough circuit breakers, fuses on the unit, I'm not talking about ours, I'm talking about any unit, marine air conditioner out there, it will shut itself down at the right time. Hopefully it was designed correctly. One thing I want to mention here is, as you do your surveys, it's important to, I think you may want to look at what refrigerant is being used on what equipment. The new trend is that due to EPA restrictions, there's new refrigerants coming into play. One of them is A2L refrigerants. A2L means slightly flammable. So I don't want this to scare everybody. I mean, there are obviously boats are out there with propane tanks and things like that, and gas grills and everything else. But the new refrigerants coming out are rated as A2L. We are still using R134A, which is the same in the same refrigerant used in the automotive industry that you may have in your car. We are switching to 513A, which is A1. A1 means it's not flammable at all. But these are the refrigerants that you will see out there. Most of the big brand ones are switching to one of these. R454B and R32, and they're considered slightly flammable. So why am I mentioning this? It's the amount of refrigerant in those units are low, but if there is kind of some sort of a spark, and if there is like a little bit of a leak, it will not explode, but it will catch on fire, and it may grow the rate of the fire faster. And it is not, it can be put out with regular chemical fire extinguishers. It doesn't need anything specialized like the lithium batteries. So, and the other category I want to mention is A3 refrigerants. They are considered flammable, extremely dangerous. Isobutane and R219 propane. Propane is literally the propane that we're talking about, and they are used as a coolant, as a refrigerant, and they are typically used in refrigerators. Marine refrigerators have actually, when you go even at home, residential refrigerators, when you look at the new ones, if it is 2024 and forward, you're going to see most likely an isobutane refrigerant inside. Marine air conditioners marine refrigerators are using either one of those. The amount is small. We're talking about 150 grams, 200 grams, 250 grams, but it is a combustible refrigerant in the air. So I'm going to stop there on this general overview. Should we do questions now, or should we
The question.
play
by all
with
means.
technology, or how do you want to proceed?
Let's play with technology.
We're in
Okay.
your hands.
So, we have it, this is a true 12 volt compressed DC air conditioner. And we have a simple demo kit here. This is seawater temperature. Obviously, we are replicating it. We just saw us filling up the tank here. Typically, when we are doing it on the marinas or anything like that, it's much easier to just dip to get an actual seawater temperature. Below the temperature, currents, and you have, I'm sorry. Yeah, battery voltage, yes. So this is our, as I said, this is our own design. We did the user interface as well. So a couple of things. When you turn on the unit, you're feeling free to come up here if you want to. When you turn on the unit, it's basically kicks into the blower, it activates the blower, and then we'll start running the unit. So since we're on land, I'm actually using a secondary pump there as well, just to be able to circulate the water through. So we're actually circulating the water through this unit. And as I mentioned, variable speed compression. This is how we are able to, with our software, we're able to speed it up and speed it down. And you're actually seeing the empties from with the water pump. I haven't seen anything like this out there yet. What's the over? The over. You want to be looking on the
What's the BTU?
It's not, it's so.
Whatever you want.
Great question. So with the numerator, if the air conditioner has a variable speed, you're gonna see something like up to between this and this range. So this unit is 5100 BTU, 5100 BTU. You will see some, basically the listings of range, they will say, if you just say 1 ton, and it will go up to 12,000 BTU. So that means they're we can slow it down, speed it up, and we can
The VFD in there is only up to 50.
Up to, yes, and the maximum capacity they're saying that is 3,700.
What's the low?
This one is 3,700.
Okay, so I'm going to approve there. I guess it's come out with a new unit that's variable VFD from 5,000 to 18,000.
Right.
And it's computerized, you have to program. Okay, this one you just do it.
So, well, it's following a certain algorithm. This is our the second generation model. We're actually working on larger capacity loads. Obviously, the higher you go, you have to also bear in mind your temperatures grow. Maximum temperatures grow. The more it's going to, once you get to our limit is going to be 1 ton. Once you pass 1 ton, it's going to have to be recommend distributed systems. Looking at 16,000, 8,000, 24,000, the signal BTU multiple doctrine is just not an efficient model of training.
I did a survey of sales of seven. So, that was a 50%.
Yeah.
And cabinet, battle cabinet.
We have had customers that had 4 of these, 1 in each cabin. And they wanted to run it while they're at anchor.
Oh, he was totally up for it.
Yeah,
He had solar panels that charging 48 volt system. That was charging 24 volt system. 2 alternates on each engine.
right.
That called a 24 volt And then you had the air conditioning, so the wires went on all air conditioning stuff. This guy said he could run for 7 hours on the battery with all air conditioning was. So we tested it. We were there at 6 hours and the battery went down like a snake.
Well, that's the catch, but it's how far do you want to go at the capacity? And but it's not like, our customers have expectations of like trying to drop the cabin to 65, 60, and 95 Fahrenheit day. That's no air conditioner is going to be able to maintain that. Air conditioners, these are, most air conditioners out there are typically called comfort, they have designed called comfort cooling. What comfort cooling means is designed for dropping the temperature down 20 degrees. Beyond 20 degrees, it will basically, any of the brand names that you think about, in a hot day, 95-degree day, it will drop it down to 75. It will not be able to drop it more than that. And obviously, the biggest thing about marine air conditioning is seawater temperature. I mean, it's a confined space. I'm just going to lower this voice for a second. It's a confined space, seawater temperature. You're going to see that rise up. Like this, if you work on this continuously for half an hour, 45 minutes, you're going to see this rising up basically quite fast because it's contained space. But in the ocean, it doesn't matter, but it's if the water is like Miami waters, when it's in the summer, at the peak of the summer, the temperatures are 101 degrees. Those air conditioners are going to have a tough time if they are not able to, if they don't have that kind of expansion involved in it. Because we can precisely calculate how much refrigerant can go into the evaporator at each given time based on the seawater temperature. We're calculating all these in our algorithm, we're taking those in and calculating, and arranging it. One of the few things that we have done is, so this is the control panel that can be mounted on the side. The slide down here, if the footprint is an issue. Otherwise, it's going to be mounted somewhere in the 4 feet. There are things here that we don't tell the customers typically, but this is our during expansion valve driver, but it's also a service screen that we did. So you're actually seeing the superheat value. Does anybody know superheat? It's the temperature difference between the refrigerant coming out of the evaporator and the pressure temperature, and then there's a pressure reading at that point. That correlates to the temperature on the theoretical table, and that difference is the superheat. The lower the superheat, the more efficient it is. Most of the air conditioners, residential air conditioners, the heat pumps that everybody's raving about, that you read about all the time, they are going to maintain superheat of 10 to 14. But we're running this, we program these machines to maintain superheat of 6. It's efficiency. The lower it is, the better. And you don't want to drop more than 4, otherwise it will create the temperature. It will change the pressure. What we are doing here is our algorithm is actually we can calculate. We're getting a our COP rating for these units is all the way is close to 7.5. Typical COP of air conditioner is between 4, 4.5, 3.5 to 4.5. Our EER, our units are only cooling. Our EER, energy efficiency ratio itself, is close to 25. Typical heat pumps that we know of in the marketplace, they do about 15 to 17. So this is you can see this is the low side pressure. You can see it on a digital screen. And you don't have to hook up things anymore for these things. this is basically wall opening, how much, because it's an electronic valve, we can dictate what percentage it should be running. So it's actually, it's only opening 5%. And then it's the evaporated temperature. So we have these new features, that makes the guesswork out of the equation when you're trying to troubleshoot diagnosis and so. And then we have there's some service screen mode here, so when the technician can go in, they can actually troubleshoot directly what the issue is. This is cooling only. We only focus on cooling. I've seen reversing valve that once they get stuck, it's a major surgery. And most of the time, the technician, when they call the technician will say, I'm gonna, if he or she is good, they will say, I'm gonna take it back to the office and cut it open and replace it, because it will be a surgical operation. Or they typically, most of the time, they're gonna say, no, you need a new one. Here you go. And that just doesn't make any sense. You just spent $3,000 on an air conditioner just because reversing valve isn't working. And it's such a silly mechanical thing that has to build up pressure behind it and it needs to slide forward. It just doesn't make any sense to me. It's in terms of those, the way they're designed in the marine air conditioners, they put it also right in front of the evaporator here. It's a, I don't know, it's, some people are happy with it, sometimes it will work when it's working. But once it stops working, they're gonna end up replacing the unit. If that's solved the problem, that's great. It just made $1 million right there. You saved the day.
I've had, yeah.
$5, it just saved the day with $5 labor bill.
24 volt anyway.
So, right now, this unit is 12 bit. We also have a unit that's coming out 12, 24, 48, and take all three of them. It's one pound limit. So,
It seems like it's very quiet other than your.
Yeah, I mean,
circulation pump.
there's other pump that's making the noise. This is actually
Yeah.
running, and this is the pump. You don't even hear the
Nice.
compressor.
And we have customers that put the unit right under their bed in their cabin.
So, yeah, there's a catamaran company out of South Africa that they basically chose these units to put it right underneath the berth, and the intake is right underneath. And customer, literally your head will be right above here. There's a compressor running in here right now. And the noise you're hearing is actually the blower.
Lord, yeah, nice.
What's the current rate on your screen there? How much it's, what the,
19.
the variable speed on the compressor?
So right now it's basically trying to cool off the whole place to 64 degrees, which we'll never do. But if we were to catch up, this is the beauty of variable speed. In our programming, it's so fast. Let's assume that it's caught up. Now watch this.
So right now it's at 100%.
Well, it was.
Well,
It was.
and then
Now
that was
I'm completely telling it to catch up.
with the average.
Wow.
Yeah.
VFDs are great.
There's, as I said, our software is doing its thing, adjustment as well, and it's gonna drop down to, I've seen it drop down to 7 amps. At that point, it's like a refrigerator in a boat. We typically, for these units, we typically suggest like a 200 amp hour house bank is enough to keep up the peace overnight. Because don't forget that there's also a refrigerator running, anchor lights running, cabin lights running, they may have TV or stereo running at the same time. And this is basically, well, this unit is rated at 12.1 amp hour. In average, so, you're running it for 8 hours, 98 amps. In average,
What refrigerant is in there?
so it's down to 10 already, and it's keep going, it will keep going.
Which refrigerant is running in that one?
R134A, and we are going to switch to 513A. It's a blend of, one of the good things, by the way, I should mention, on the refrigerant side, I'm gonna go back here. So R134YF, the whole industry is gonna eventually go down that road. That's going to be maybe 10 years down the road. But R134YF has a global warming potential of 4. Typical 410, R410, that's used in most commonly in residential as well as known brands, marine air conditioners, have a global warming potential of 1,847. So when you switch to R454 and R32, they're blended gases. So they actually have a blend of 1, 2, 3, 4 YF in them. That's how they're able to lower the global warming potential. Basically, when I say global warming potential, it's the multiplicator factor of the carbon emissions. Think of carbon is 1. Global warming potential has 1. 1, 2, 3, 4 YF has 4. So at that point, you can practically open it up to air and you're going to be okay. But that's going to be further down the road. That's what the direction of the industry is going. Either going to go to this or they're going to go to these refrigerants.
That compressor can take it.
This compressor, our compressor, we are ready for it. We can switch to that tomorrow. The thing is that YF is very difficult to find in large quantities. You can go to AutoZone and get a small can, which these units take about 240 grams, so it's about 2/3 of that can. But if you were to power up a larger unit, and when you're in the production side, in the industrial scale, it's very difficult to find large amounts of YF. So most of the refrigerant service guys won't even carry YF. They haven't even transitioned to YF yet. They will start to have R32 most commonly. R32 is very common because the residential split systems are mostly coming out beginning 2025 with R32. And then R454B is also out there with the chillers and so forth, with the marine chillers and so forth. The new ones coming in 2025. That's what I wanted to mention in terms of the refrigerants. So
Does each unit have to have, you said 200 amp hours? So what's the distance? I mean, you have to calculate the draw, the wiring, correct?
yes. I mean, we basically with the installation, we definitely recommend a 20 breaker
Oh, yeah.
before tying up the unit, before tying up the unit to the rest of the boat. So there has to be like for the breaker, just to be able to isolate. And then with that, between that breaker and where the battery band, you just have to follow the UIC tables for
Yeah,
wire
wire
gauge.
size.
Obviously, closer is the better, but it never works out that way.
So
Yes.
in the world of smaller recreational boats, I'm not thinking about, bigger boats with more complex, larger systems, but with the efficiency and capacity of batteries getting ever so big, do you see like these small DC units replacing AC powered units on smaller boats?
Oh, totally. I mean, we have had customers that would just say, I'm okay with the alternating currents existing system. It's already built in and it's working fine when I'm on the dock side. The most common question we get is like, can I tee it to the existing dock? It's possible to do that.
Mhm.
And basically that you can run a unit like this offshore when you're at anchor or something like
Yeah.
that, and then use the same ducting. And when you're tied up to the dock with shore power, you can go back to your existing units and run that. We have had customers with this unit got installed, I think is a 36-foot boat that they said on the sailboat, they said they just closed the V-berth and then close off the entire rest of the boat. It's technically rated for 500 cubic feet of air volume. In terms of size, but it seems like people are using it for more than that. We also have customers, a lot of customers, because of its compact space and because of the power draw, we have had customers that are on center consoles. I just want cold air blowing in my face. And they can power it up from the alternator of an outboard. Its draw is so small that the alternators that are coming out on the outboards now are so much. You can easily get 40 amps out of those. It's less than it takes less than half its top of that. So there we have that. I just want cold air in my face.
This would even be good in RVs.
So water cooling.
Campers, water cooling.
If you're down by the river, yes.
Yeah.
What's the cost of this size unit?
The retail is 3,200.
You mentioned a South African manufacturer putting it, are there many OEM manufacturers putting them in new boats now?
We're new still, and we're just making inroads on that actually. So far the customers have been retail customers or US law enforcement agencies in the South that they have a lot of power boats that they're using. And it's just because you can access it and so forth, and then it's support. Any other questions?
How long to boil all that water in the tank? How long would it take? Roughly.
It's not gonna boil it. So we started around 71 Fahrenheit. So
We've gone
it's-
down significantly in the lower temperature, but only a few degrees.
the temperature, we are okay with all the way. Well, I don't know the boiling point in terms of, we're not gonna get to 212, 212
So
Fahrenheit.
depending on the size of the.
It will
water
shut
tank,
itself off before that because we can detect the water temperature, even the water temperature. So it will shut itself off before it gets to a boiling point. However,
I think
it will,
like in an RV with like a
That's
dedicated
it.
like
I'm
cooling
trying to-
water tank.
My dad's dream. It's like, we can put this in an RV, it's like, no.
so you can do that. I mean, there are ways to do that. If you, so you can take a existing 6-gallon, if you take a 6-gallon water tank from a water heater, electric water heater, if you rig it up to take the water from this side, that's the seawater outside,
Can that water be repurposed?
and then you can circulate it. You can probably use that for a good an hour or two. After that, it probably will be too hot to run it again. And as soon as if you can put a valve in there that you can top off the water and to cool it down a little bit, you can then keep going.
Water tank with cooling fins
You
on
make
it.
a hot water.
There you go.
What material are you using for the condenser flow? Is it condenser flow?
Condenser is cupronickel, yes, it's made by Tuppertech. 80% of our material is US source. There's still obviously some components has to come from overseas, but lately our biggest problem is we use every aspect of the metal part is aluminum, 652, and we are having tough time in terms of getting the price right. So there may be some price increase down the road. But we are not gonna go back to the metal sheet base or anything like that. We just took that out of the equation. The drain pan is ABS plastic. Every component of it is field serviceable. You can take this drain, if the customer cracks this piece, it's easy to take it out and move it out and put a replacement in. We have everything else in stock. We have multiple sensors. The actual unit has 2 service valves, just traditional service valves, not one. It can be field charged if need be, topped up. And the fact that this is using R134A, we have a lot of 75% of our customers are Florida based, so they're Caribbean cruisers. We tell them if you are going to be going away for a long time, just grab a can from an auto shop, one of those cans, 2/3 of that can is enough to charge off the entire unit. And you can top it up if you would be. Although we don't recommend that. Any other questions? Overall, on the screen?
Yeah.
Right.